All right, so I just have another little sort of side iteration that I want to introduce, and that's the idea of flattening, right? So what you're viewing, and I introduced this before, but I'm just going to go over it again to make sure it's all in one place. What you're viewing is essentially branches of a tree. Okay, and the simplest form of envisioning this is to go into the param viewer, which is found under params, under utility, and it's right here. It's called the param viewer. And it just gives you a visual picture of what the data looks like. If you plug it in and you go to draw tree, you'll see the number of steps you've taken to develop the geometry that you have there, where it was broken, where the branches came from, what their origin is, and you can kind of trace it back to kind of view what the original data was. So the point that I'm trying to make here is that when you break down the trees, the tree branches, and you flatten it, you're no longer dealing with you're basically kind of cutting out all the branches of the tree and you're just looking at the trunk, right? So it's one solid linear format of all the information that still exists, but it has to read it in a particular order. So while right here we have our 0, 1, 2, 3, 4, all the way up to 10, and that's our list of lines right here. We also then go into the next line, 0, 1, 2, 3, and then 0, 1, 2, 3, and then 0, 1, 2, 3, so on and so forth, all the way down, and it actually gets read in a sort of zigzag pattern. So if it gets flattened, and let me, it's going to take two flattenings here, so I'm going to lock the solver, and then flatten, and then flatten, and then unlock. This is what happens. So rather than reading it in now sets, it's reading it as a complete list all the way up to a 0.65. And I'm going to pop back on. I mean, the numbers are still on, but let me pop the draw order on, and now you'll see really the visual nature of its zigzag pattern. So it reads 0 to 1, 1 to 2, 3 to 4, and it goes, whoops, sorry. I have no idea what you want me to do. So it goes all the way to the end to 10, and then it returns back to where the second set of data was, and it continues the count. It goes 11, 12, 13, 14, so on and so forth all the way down. That's important to know because now that I've modified my pattern and I made it entirely parametric, it is a sound parametric pattern. It then recalculates the range of numbers, and it goes from 0.75 to 1.97 throughout 67 numbers. Now this one only has 50. That's 65. Why is it only reading 50? That's odd. Oh, because it's the count of cells. So in this case, the count of cells, because now we're doing it around not just one linear relationship of cell to cell, we now have to think about both directions. So I've got a number of extra points and less cells. So I would, in this case, because it's all flattened, I know that I have exactly the same number of points as I have circles. I would plug in the P output, and so now my count is going to go to 65 or 66. Clear enough? So that one's a really simple, just kind of closure thought about the last part of the organization of these patterns. What questions do you have? Probably none in the last minute and a half. So. Mohammed, you look really lost. You all right? All right. So what I'm going to do is I'm going to come around. I'm going to make sure that you guys have this all caught up here. We'll take a break, and then we'll get back into something that's a little bit more complex.